What is earthquake analysis? Earthquake analysis is the process of evaluating the effects of an earthquake on a structure or region. It involves a range of techniques and methods, including seismic hazard analysis, structural analysis, and ground motion simulation. Earthquake analysis is crucial for understanding the potential risks associated with earthquakes, and for developing effective strategies to mitigate those risks. Seismic hazard analysis is a critical component of earthquake analysis. It involves assessing the likelihood of an earthquake occurring in a particular area and the potential magnitude of that earthquake. This information is used to inform building codes and other regulations, as well as to guide emergency preparedness planning. Structural analysis is another important aspect of earthquake analysis. It involves evaluating the response of structures to earthquake forces, including both static and dynamic effects. Structural analysis can help identify potential weaknesses or vulnerabilities in buildings, bridges, and other infrastructure, and inform retrofitting or design decisions. Ground motion simulation is a technique used in earthquake analysis to model the behavior of earthquake waves as they propagate through the earth. This simulation can help predict how seismic waves will affect a particular location, and inform decisions about where to locate critical infrastructure or where to avoid building. Overall, earthquake analysis plays a crucial role in reducing the potential impact of earthquakes on society. By understanding the risks associated with earthquakes and developing effective mitigation strategies, we can work to protect people and infrastructure in earthquake-prone regions. How is earthquake analysis done? Earthquake analysis involves several steps and techniques to evaluate the potential impact of an earthquake. Here are some of the methods used for earthquake analysis. Seismic hazard analysis. It is the first step in earthquake analysis, which aims to assess the probability of an earthquake occurring in a particular region and the potential magnitude of that earthquake. Seismic hazard analysis involves a range of techniques, including historical data analysis, geological and geophysical studies, and computer modeling. Structural analysis. Structural analysis is a critical component of earthquake analysis, which aims to evaluate the response of structures to earthquake forces. It involves studying the behavior of structures under static and dynamic loads, including the effects of ground motion, and identifying potential vulnerabilities or weaknesses. Ground motion simulation. Ground motion simulation involves creating computer models that simulate the behavior of earthquake waves as they travel through the earth. This technique can help predict how seismic waves will affect a particular location and inform decisions about where to locate critical infrastructure. Site response analysis. Site response analysis is used to evaluate the behavior of soil and rock layers underlying a particular location during an earthquake. This analysis can help predict how seismic waves will be amplified or attenuated at that location, and inform decisions about where to build critical infrastructure. Tsunami modeling. Tsunami modeling is a technique used to simulate the behavior of tsunamis, which can be triggered by earthquakes. This technique can help predict the potential impact of a tsunami on coastal communities and inform decisions about evacuation and other emergency preparedness measures. Risk assessment. Risk assessment is the final step in earthquake analysis, which involves evaluating the potential impact of an earthquake on a particular region or infrastructure. This analysis takes into account the results of seismic hazard analysis, structural analysis, ground motion simulation, site response analysis, and tsunami modeling to assess the likelihood of damage or loss of life. Overall, earthquake analysis is a complex and multidisciplinary process that involves a range of techniques and methods. By using these methods, experts can better understand the potential impact of earthquakes on society and develop effective strategies to mitigate those risks. Please don't forget to subscribe to my channel and turn on notifications.